So everybody is aware of the network, correct? Na? So everybody is aware of the networks because you are already did engineering, and some of you are already working in IT only. So most of you know about the LAN. Okay, LAN means it's local area network, correct? Right? Means it is a network where the computers are interconnected each other. If the computers are within the premises, we call it as local area network, or if the machines are connected between two different premises, we will call it as WAN, wide area network, like that. Okay, so the same concept goes for the cloud as well. But in the cloud, we will not call this as a local area network, we will call it as a virtual network. Why we call it as a virtual network? Because this network you cannot feel it, you have to imagine it. Okay, because it is somewhere in the remote data center, you will just define your own network IP address. Okay, then the classes you will define, right? So that is why we call it as virtual network. So in the Azure we'll call it as virtual network. If I talk about the AWS, they will call it as virtual private cloud, VPC. Okay, the terminologies are different, but the actual work and the concept behind that is same. Okay, so let us get started, then let us understand what is virtual network, or what are all the other network resources we have in the cloud. Okay, so as I already told you, virtual network means it's an Azure network service which is used to represent your own network in the cloud. That's what I said. Virtual network is nothing but it is a kind of LAN at your on premises, but it is there in the cloud. Okay, since this local area network is there in the cloud, somewhere in the remote data center, we will call it as a virtual network. And the representation of the virtual network, you can see it below here. Let me take the pen. Yeah, you can see the representation of the virtual network will be like this. You can see a parallelogram with less than symbol, greater than symbol, in between three dots will be there. Okay, if you see in solution with this diagram, that tells you that is a virtual network. Okay, the representation of the virtual network will be like this. You will have a parallelogram, okay, like this, and you will have a greater symbol, okay, and with three dots. That represents the virtual network. We call it as Vnets. Okay, that is the one of the Azure network services. Okay, that is very important in order to build a virtual machine, in order to build a load balancer, anything that you want to build with respect to the, which is having the IP address. Every services in the cloud we will have an IP address, because that is somewhere in the remote data center. In order to access that, you should have an IP address, right? So this is one of the network resources, and the representation is like this. Okay, and what other network resources we have in the cloud? Okay, we have the first one is virtual network. Now you know it is a logical representation of your network in the cloud. Okay, and since it is placed in the remote data center, we call it as virtual network. And you will also have the IP addresses. Okay, so the IP address are, there are two types of IP address, you already know. One is private IP, another one is public IP. The private IP means the IP address which is used to communicate within your office network or within your private network. Okay, such IP addresses are called as private IP address, and these private IP addresses are free of cost. You don't have to pay for the private IP addresses. You can, there are 5 classes of IP address: class A, class B, class C, class D, and class E. And out of 5, the first 3 classes, class A, B, C, these 3 classes can be used. And in each classes of the IP addresses, we will have one dedicated network range kept for the private usage. Okay, the remaining all are used for the public usage. Okay, so now you know private IP means the IP addresses which can be used within our office network, within our private network. Those IP addresses called as private IP, and those IP addresses are not exposed to the internet world. By sitting at my home, I cannot access the private IP which is there in your office, or which is there in your home network. Okay, but the public IP can be accessible. Why it is public? Because that IP address is exposed to the external world. Means anybody can access the public IP. Like we have this private property and public property. Okay, say for example you have your own car. Okay, you will not simply allow everybody to sit inside, but we have the public transport. The public transport can be used by anyone, not only our nation people, any people from the world, our entire world can be used the public, because it's a public property or it's a public asset, right? Similarly, public IP means it is exposed to the internet world. If you have internet at your home, I can sit at my home and access the computer which is having the public IP. Say, for example, you have a laptop and your laptop has got a public IP. By sitting at my home, I can connect your laptop with the help of the internet. So, since it is exposed to the internet, the chances of no, the risk is high, because anybody can penetrate, anybody can try to log into the PC, anybody can try to no, no, give the ransomwares. Okay, so this kind of attacks or any kind of malicious activity or any kind of no virus infection can be possible. Okay, and that is the reason public is always a risk, private is always a secure one. And public IP you have to pay for it. If you have a public IP, per year you need to pay around 2000 rupees or something in Indian currency. Okay, so private means it is within the network, public means it is outside the private means it's a public, it is exposed to the public network. Okay, there are two types of IP addresses. The next one is load balancer. This is one of the very important service that we are going to learn in our upcoming classes. Okay, the load balancer means this is also one of the network services. Okay, the usage of the load balancer is, say for example you have critical applications. Okay, so you have some critical applications here, and if you are having a standalone servers, right, if you have your standalone servers, the risk is high. Okay, say for example you have an application called Facebook, and you go to the Google Chrome and you will browse facebook.com. Then if you have a single application server here which is hosted the application called facebook.com, and when you hit, you are sitting here and you are hitting this in your browser, then the application will be routed to this computer. Imagine for some reason this Facebook application server got crashed. Okay, it is not available, then whoever is accessing the application will not be able to access the application, correct? Now, because it's a single point of failure. If you have this kind of single point of failure or single noded application which is very critical application, then your business will never have the continuity, or your business will never have the redundancy. It won't have the performance. Okay, so to avoid that single point of failure, we have a concept called load balancer. Okay, the representation of the load balancer will be like this in the Azure. Okay, so what they will do, this load balancer will have an IP address, maybe say for example it is 192.168.1.10, and for this IP address I can create a DNS entry called facebook.com. When the user hits, they will not be able to remember the IP address, because we are all human beings. For us, it is easy to remember the strings or the names, but it is very difficult to remember the IP address. That is the reason we use the help of the DNS. This is domain naming system, which will help us to resolve a name to IP address and vice versa. Okay, so what you will do, you will create a record called facebook.com in the DNS, and you will assign the IP address called 192.168.1.10. As and when you enter www.facebook.com, this DNS will search for this facebook.com and understand the IP address, and it will route the query to this IP address. It resolves the name to IP address. So here behind the load balancer you have at least minimum 2 application servers, or maximum it can be anything, but in my case let me put 3 application servers. So this all the 3 application servers are the replica of each other, they are identical. Okay, the same data is here because the data will be in the some other tier. Okay, if you consider tier 2 application server, say for example this is your database. Okay, this is your database. So all these application servers are consuming the database from the same server, but these application servers are added behind the load balancer here. Now you here as a user you are hitting www.facebook.com and that is getting converted to this IP address, and this IP address is the IP address of the load balancer. So this load balancer has got a capability. It will talk to these three servers and it will ensure all these three servers are up and running. For any reason, whenever this load balancer try to talk to the server 1, if the server is not responding in 5 to 10 seconds, this load balancer will consider this application server is unavailable. Then it will not send a request to this application server. It will only send here and here. If 100 users are logging into the application called Facebook, this load balancer equally divide the load. Okay, it equally divides the load. Okay, so what it will do, if the first application server is also working, it will send here 33 request here, 33 request here, and 34 request here. Due to some reason, if the server gets crashed, it is not available, then what it will do, this 33 already there now. So what they will do, it will automatically redirect the user from this faulty applications to this working applications. That it will send the load 50 here, 50 here. This is the concept of load balancer. Okay, this is very important. What it will do, it will ensure the application availability. The application redundancy is high. Even if two server goes down also, it won't go, the third one will not go, because these servers are kept in the availability zones. If you remember, I was telling you under each Azure region you will have a availability zone. So Microsoft tells you if you want 6 digits of 99.9999% of the SLA, then you keep each and every application servers in the different availability zone. You keep this in Mysore, you keep this in Bangalore, you keep this in Mangalore. Okay. So even for some reason due to tsunami or some flood, even if the Mangalore server goes down, you still have one Bangalore and Mysore, two servers are there, because each and every availability set is minimum 200 to 250 kilometers away. So it is unlikely no two regions will be, or no two availability zones will be impacted at the same time. Keeping that in the mind, they have designed the data center such a way. Okay. So this is important. This is load balancer. Okay, we will learn about this during our load balancer class, but now to keep you an understanding, I have explained that. Okay, we are done with the load balancer. Then the application gateway. See, this application gateway, it is a kind of web. It's a kind of security. It is that is also kind of load balancer only, but this increases the application security. Means if you are typing www.facebook.com, you are typing www.facebook.com. Okay, but indirectly this will mask the identity of the application and it opens the linkedin.com example I am giving you. Okay, so you are telling to the external world your application server is like 192.168.1.10, but this will be masked, the whatever the behind the application server, the actual in identity of the application server will be masked. Okay, it will change the actual name or actual identity of the application, and it will try to access, it will allow you to access the application. So basically this increases the application security. Okay, I'll explain you all those things in the future class, but now you let us understand what are all these. Okay, then the traffic manager. So this traffic manager is also, it's a DNS based load balancer, we call it as. Okay, you might have seen, so today you are in India, if you type www.facebook.com, it will just quickly able to open the application. So tomorrow, due to some business, you went to US, and there you just you are sitting in the airport, okay, lobby maybe. There you are just holding your phone and typing www.facebook.com. So that time, will your application server will come to India and connect to the application server? No. that increases the application delay. Okay, that's why we always hit the traffic manager. This traffic manager will sense, okay, the user today is in India. How it will understand? It will understand the nearby DNS and understand where exactly the DNS is there, and the application will be getting the connection will be established to the nearby server. But if you go to the USA tomorrow, again there you type www.facebook.com, that has to be resolved to the IP address. That means it has to contact the DNS server. So that DNS server is there in US means it will never send the connection to the Indian server, that will send the connection to the USA server only. So that, like that, this traffic manager, it's a global DNS, I mean it's a DNS based traffic manager. Okay, we will study more about the traffic manager in the upcoming classes. You should have this understanding. Okay, now NSG. NSG means it is network security group. I told you, say for example, I am stressing the important topics more, you have to keep it in mind. Okay, say for example, you have a region, I mean you have a location, this is your Vnet. Say for example, this is your Vnet. The Vnet range is IP address 10.0.0.0/24. It's a 254 IP address will be there. It's a /24 network, and you have another office here. Okay, so any traffic between this to this one will go via firewall. Here you will have the firewall. The firewall symbol is this one. Okay, any traffic comes, that's go via firewall. Imagine you have servers here. The traffic which is going outside of this network or which is coming inside of this network, it will always go via this firewall only. The firewall is nothing but it is a node from which all the traffic to that particular network or from that particular network goes out and comes in. Okay, that is called as firewall. There we will monitor each and every packets. What data is going? Is there any images going? Is there any movie going? Is there any secure username and password is going? Or is there any malicious traffic is flowing inside the network? Everything can be monitored in this firewall. So basically, a firewall is a security device. You will monitor both the incoming and outgoing traffic of the network. Okay, that ensures your network, everywhere estate is secured enough. Okay, that is called as firewall. Similarly, the same firewall will be there in the computer as well. So whatever I am talking here, this is a hardware firewall, or now it is appliance, even software firewalls also there. But inside the operating system also you have a firewall. If you see, if I go to command prompt and type firewall.cpl, you can see the firewall here. See, if I open, it shows the Windows Defender firewall. See, I have turned off. Normally it should be on, it will be on like this. Okay, see here you can see it is on. Private network is on, public network is also on. Means now most of the traffic of my computer is blocked because I have turned on the firewall. How it is? You can see here, if I see the firewall rules here, see here it says allowed apps and features. If you see here, branch cache content retrieval use HTTP, that network is not allowed. See, it is not checked. So if anything related to this, the traffic related to this branch cache, it will never allow because it is not allowed here. See, whatever you see, the checked one, those traffics will be allowed. Whatever is unchecked, it is not allowed. See, file and printer sharing. If I uncheck this one, you will not be able to access your file and folder from the other computers because that blocks the SMB traffic. Okay, so like this we have firewall in the multiple level. Okay, let me turn off this one. Okay, so in the cloud, thinking that this computer is placed in the somewhere in the remote data center. Okay, so Microsoft and all the cloud provider, they have introduced one more level of security. Okay, that security in the Azure we will call it as NSG. NSG. NSG means it's network security group. It is network security group. Okay, we call it as NSG. So this NSG rules can be applied at two levels. So each and every VNet will have subnet. Say for example, if let me make it as 16/16. So /16 means it is around 65,534 IP address will be there approximately. Okay. So if I use all the /16 network for a single VNet, it is waste of IP addresses. So what I will do, I will create a small network within a bigger VNet. A big VNet is there, under that I will create a small subnet. Okay. Say for example, now you have a VNet here. This is a bigger /16 network. Under that, what I will do, I will create a small network called 10.0.0.0/24. So this will this is /16, this is /24. So my first IP address is this one, 10.0.0.1. second is 10.0.0.2. last IP is 10.0.0.254. This is my IP address, last IP address. Okay. So what you can do, you can create an NSG at this subnet level, link it here. Okay, and you can create my subnet 01 NSG 01. And what you can tell to your subnet, you need to allow only the specific traffic. Okay, if I want to enable RDP, you have to create a rule called incoming rule. Go to the NSG and create a new incoming rule. Yesterday I created it was not pinging. Then I created an ICMP rule. Correct na? Star any. I put ICMP connection allowed. Then I started pinging the computer. The same like that. You can apply this NSG at two levels. One is at the network interface card level. Another one is at the subnet level. You can also apply, this computer will have a NIC card. Okay, say for example, this is a NIC card and the cable goes here. So this one also you can create an NSC and you can apply. That is very granular level filtering. Okay, it is very difficult to troubleshoot if you apply the network security group at the computer level, NIC card level. Okay, it is a best practice. You have to always keep the NSG at the subnet level, not on the network level and network interface card level. You can keep, but troubleshooting will become very tough. You will face lot of challenges in the future. Okay, so that is called as network security group, where you can apply the network security group. It is the network security group, nothing but the firewall, a kind of firewall which you can apply at the two level. One is at the network interface card or the NIC card level, another one is at the subnet level. So where you can create incoming and outgoing rules, the traffic rules. By default, all the outgoing traffic is allowed. By default, all the incoming traffic is denied. So there is a rule created with higher priority. Okay, I'll explain you when I do that network security group. Maybe tomorrow I'll do that. Okay, so there lesser the number, higher the priority. More the number, lesser the priority. Okay, for the rules I'm talking about. Okay, I'll explain you that tomorrow. Okay, is this clear about the NST? NST is nothing but it's a firewall which can apply at two level. One is at the network interface card level, another one is at the subnet level, which will allow you to create the incoming and outgoing rules, traffic. You can allow incoming and outgoing traffic. Okay, that is the NST. That is one of the important topic. Okay, because in your day-to-day work you will do the creation of NSG rules, all those things. Okay, so that is about the NSG. So you have this forced tunneling, means say for example you want to talk with two different location. So one location is Hyderabad, another one is Bangalore, Chennai. Three locations are involved here. Imagine. So if you want to send the traffic, you can directly send from Bangalore to Chennai, or you go to the Hyderabad, from Hyderabad you go to the Chennai. So like that you have the combinations. Maybe with respect to some application requirement, you are forcing the traffic to take that particular tunnel. Okay, you will tell don't go directly to the Chennai. Okay, because we have some database server in the Hyderabad, so better you go to Hyderabad. From there the next stop will be Chennai. Like that you can force, you can create a tunnel to force some traffic, that is called as forced tunneling. Okay, that is also network requirement only, network resource only. Okay, and then regional VNets. Okay, this called as regional VNets. Okay, there are two types of VNets. I mean, you can use two types of connectivity. One is local VNet peering and the global VNet peering. Means if you have the virtual network within the same region, we call it as regional VNets. If you have VNets between two different regions, say for example, Western Europe you have one VNet, Eastern Europe or USA you have one VNet. Okay, those two VNets are not the regional because both the regions are different. They are global, right? So by default, no two VNets will have the communication. If it is regional or if it is different regions also, by default the connectivity will not be there between two different VNets. Okay, then you have to establish the connection. If you want to, if you want your computer to talk to another VNet, right, then you have to establish the connection. Say for example, you have a VNet here, you have another VNet here. Say for example, this is also one VNet. This is Western Europe, this is USA. Okay, so you have a computer here, you have a computer here, you have a computer here. So here, if you see, all the VNets are different, 10.0.0.0/24. This is maybe 11.0.0.0/24. This can be 12.0.0.0/24. So all are different network, because it is 10 is here, it is 11, it is 12. So different numbers means different network. Okay, by default when you try to log into this computer and ping this computer, okay, maybe this IP address is 10.0.0.10, this one is like 11.0.0.0.10, this one is 12.0.0.10. Okay, so this is okay. So you are logging into this 10.0.0.10 and trying to ping 11.0.0.10. By default there is no connectivity because both are two different network. Now also see, if you are in office, each and every, say for example there are two buildings. Okay, building A, building B. If there is no router or if there is no networking between, you will not be able to communicate between two buildings or two computers also. Okay, that is what we will do. We will enable the connection between two different VNets, that is called as peering. So there is an option called peering. When you enable the peering between VNet 1 and VNet 2, okay, then 10.0.0.10 will be able to communicate with the 11.0.0.10. If the VNets are between the same region, we will call it as local VNet peering. Here likewise, it is in Western Europe, it is in USA. Now by default within the region only there is no communication. Similarly between the region also no communication. Then if you want to establish the connection between your Western Europe region and your USA region, then you have to enable another type of peering, that is called as global VNet peering. This is called as global VNet peering. Okay, this is one of the important topic. Okay, so VNet is important, subnet is important, and peering is important, network security group is important, load balancer is important, traffic manager is important. Okay, these are the very important network components that you should know, because in the on-premises world, management of the network will be different. You will have dedicated network team, you will have dedicated backup team, but in the cloud it is not like that. You are the one who has to take care everything. The network you need to manage, the firewall, sometimes even firewall NSG, everything you need to manage, and backup that you need to manage. Okay, and infrastructure that you need to manage. So that is why the cloud SMEs, the cloud resources will be getting paid more. Why people earn lakhs together if they learn the cloud means there the other resources will be getting cut. Instead of having two resources from the backup, two resources from the network, two resources from the Windows team, they will only hire two peoples who knows everything, full stack. Okay, and then they will get the things done. That is why they will be paid double. Okay, so this is what the Vnet peering. So now if I go back to the cross premises, see this is what the Vnet peering, and you still have this cross premises networking. So that is called as VPN connections, right? Point to point connection, point to site connections, and the express route connections. So point to point means so one point to another point. Say for example, so from your home to office, site to site means between your two offices, Hyderabad and Bangalore. Express route means the connection between your on premises and the cloud, or the connection between your one office to the another office with a dedicated lease line. Okay, so we will have a separate dedicated lease line between your two premises. Okay, not from your office, sorry, not from your home. It is between your offices only, or it is either it is between your two offices, or it is either between your office and the cloud for that matter. Okay, there you have to pay some dedicated amount, maybe 10 Mbps line will cost you about 10,000, 15,000 per month, or per year. There is some separate tariffs also there. So all your data passes through that express route. Why it is express route? Because that tunnel will be given to you dedicatedly. No other traffic will go there. That is dedicated, like you have a dedicated road. Nobody will go in that road. Okay, you are the owner of that road. You are paying for that, like nice road. Okay, we are paying and go. If tomorrow if he is not allowing, it is his own property. Okay, he can go however the way, however speed he wanted. Like that, express route is similar to the same way. Okay, where you have a dedicated route, we call it as express route, and dedicatedly give some bandwidth for that. Okay, and you have to pay for that. That is called as express route. Okay, so all these are the some network components of cloud. Okay, and if you look at here, I have to picturize, okay, where how is the components will be used. Okay, you see here I have my on premises network here. Can you see, guys? Hello?
Yes, sir.
Yeah, if you look at here, this is my on prem. In the on premises we have, this is called as local area network. Imagine this is local area network. So I have extended my on premises connection to this is cloud. This is my cloud. Okay, you see here I told now the connection between on premises and the cloud can be express route. See the logic, this is the graphical representation of the express route. This symbol is there, this is the graphical representation of the express route. Okay, and then if you see in the cloud, not everything is exposed to the external world. Okay, there are some concept called the architecture or models, like mesh model, hub and spoke. Okay, all those things are there. So a better architecture will always have the hub and spoke model. So this we call it as hub. Like in the cycle wheel, you have seen the hub. Now everything goes and connected to the middle portion. That is called as hub. And the each and every the I mean the lines will be there are the spokes actually. Okay, so if a jump box wanted to talk to this particular computer, okay, what it will do, here we have the network security group. See subnet, I told this is this key symbol is there now, lock symbol. This lock symbol means it's a network security group. This jump server is there in the cloud. Okay, this computer wanted to access this jump server. So what he will do, he will go to this gateway. With the help of gateway, with the help of express route, he will go to the another gateway which is there in the cloud, which is your hub. Okay, and here in the hub you have an NSG, and in the NSG you have defined, okay, the connectivity between your on premises and this NSG is allowed. If it is allowed, then if it is allowed and if there is a Vnet peering, okay, then you can access this computer. Okay, this is the logical representation. See here, everywhere you have NSG. See here you have gateway, means here you have your on-premises firewall. Somewhere here your on-premises firewall will be there. Okay, the traffic flows here. Then again here in the cloud you will have a NSG. See here NSG is there, and here in this subnet also NSG is there. So everywhere you have to allow. Okay, so this is the destination, this is the source. In between this source and destination, if any particular traffic comes, say for example RDP 3389, then allow. Like that you have to create the rule, otherwise you will not be able to access the resources within the cloud. Okay, so this is the logical, I mean, pictorial representation, just to give you an understanding how a solution looks like. Okay, this is one of the solution actually. Okay, any question here?
No, sir.
Yeah, you see here, just to make it even more simple, I have drawn this one. The same picture I have drawn. See, Vnet 01 has got two pictures. This is the RG01. You have a resource group. You know, right? The hierarchy. The first is tenant, and then subscription under that resource group. What I have done here, I have created a resource group RG01. Under that, I have created two Vnets, Vnet 01 and Vnet 02. And within Vnet 01, I have created two computers, and within Vnet 2, I have created two computers. When I try to talk to this computer 1 to computer 2 or computer 1 of this Vnet 02, by default there is no connection. Okay, what I have done, I have enabled the peering. So since I have enabled the peering within the same region, I call it as Vnet, local Vnet peering. If this is in a different region, okay, this is Vnet 01 is in USA, maybe Vnet 02 is in Australia, then I would have enabled Vnet, global Vnet peering, because enabling the communication between two Vnets of different region, that is called as global Vnet peering. I'll show you tomorrow about this. Okay, and then network traffic. See, these are all some of the key points actually. Down below you can see the network traffic between peered Vnet is private, means the traffic goes between two different Vnets. It is private. Why? Because private, the Microsoft has laid their own cabling between every data center. Okay, say for example, this is your India, this is your USA. Okay, sorry, I think I would have written other. It's okay. Okay, so imagine if you are pairing the Vnet between this and this region, Microsoft never uses the external public network to send the traffic, because they've already laid down their own cabling in the ocean between each and every region, and this cabling is of terabytes of petabytes of speed. Okay, and the traffic goes within this tunnel is fully secured, encrypted. Okay, hence Microsoft call this network as Microsoft backbone. Microsoft backbone. Okay, since the traffic between two different region, which is traveling within the peered network, is going through Microsoft backbone network, which is their own cabling network enabled between the regions, we call it as private network. Say for example, you have a property. Okay, so maybe the property, to go to the property you have not got the road, you purchase the road. I mean, you purchase the land and you made the road. That's your own road, right? You it is not necessarily you should allow everybody. You will only use for your usage, because it's your private usage. No, same way it goes here. Okay, and the low latency means that is a dedicated tunnel. Okay, super speed will be there. Okay, and it's petabytes, petabytes of speed will be there. That is the reason there is very less latency. Performance is very good there. High bandwidth, I told you, it has got TB, petabytes of terabytes and petabytes of speed is there. Okay, that is the reason we call it as high bandwidth, and it's called as Microsoft backbone. ability to communicate and transfer the data across all the Azure regions means you can peer the I said around 54 regions are there, right? Across 54 regions you can transfer the data, because each and every network, I mean a peered network has got the connection with other regions also. Means between all the 54 regions, Microsoft has laid down the backbone network. Their own cablings are there, so nothing to worry. You can see there are videos in the YouTube how the cabling has been done under the ocean between the Microsoft Azure data centers. Wonderful videos are there. You can just watch it and understand. Okay, and the encrypted is the transferred is fully encrypted. Whatever data gets transferred. Okay, even Microsoft don't have visibility what data goes inside, because while encrypting the data, okay, you have to generate some keys, encryption keys. Okay, if you don't know that encryption keys, even you will not be able to retrieve the data. Imagine that level of security, that level of encryption, 256 bits multiple. There are a lot of algorithms, are encryption algorithms are there. They will use that encryption algorithm, and they will encrypt the data to secure their customers data. Customer means we are data. Okay, and peerings are not transitive. Earlier it was not transitive. Now last week I created one peering, so it looks like it is a transitive. Transitive means, say for example, you enable the connection here in the Vnet 01, telling establish the connection between your Vnet 01 to Vnet 02. It is not transitive, means it is a one way. Means if you want to connect Vnet 02 to Vnet 01, again you have to go to Vnet 02 and create a connection from Vnet 0 to Vnet 01. This is called as non-transitive. See, transitive means both. If you create connection at one side, you will have both incoming and outgoing traffic. I mean Vnet 01 can talk to Vnet 02, and Vnet 02 can talk to Vnet 01 if it is transitive. If it is not transitive, it is one way. If you enable the connection at Vnet 01, you will only connect from Vnet 01 to Vnet 02, and from Vnet 02 to Vnet 0 you cannot connect. Ulta, other way you cannot connect if it is non-transitive. Okay, then what you have to do, you have to create the connection at both the Vnets. But recently I have just enabled the connection one side. I think it has become transitive. Anyway, we will check that tomorrow. In our tomorrow's class I am going to do that, and I'll show you that. Okay, the same thing, see here, 10.0.0/16 192.168.10/24. Okay, virtual network, and I am enabling the peering. So what we will do tomorrow, we will do the lab. We will create a Vnet. We will create two Vnets in two different regions. We will create two virtual machines in each Vnet, and try to establish the connection, communication, ping, and we will see whether we are able to connect or not. If we are not able to connect, then what we will do, we will enable the peering. Then we will see how the connection will get established. Okay, this is the homework for tomorrow. And I was referring the IP address, right, because most of the peoples don't know what is IP address, and all. Few peoples, okay, not most of the peoples. So just to make you understand, you can just refer this. Okay, you can take a picture of it. These are the classes of IP address, class A, B, C, D, E. Okay, and how I have to identify the classes? You see here, the first letter, the first octet will define you or tell you which class this IP belongs to. If an IP address that begins between 1 to 126, say for example 1 to 126, any IP, the first octet is starting between 1 to 126, that is called as class A. You have to look only the first letter. If the first number is starting between 1 to 126, we call that IP as class A IP address. And class B, like 128 to 191 and 192 to 223. You have to look only the first number here. Okay, and then you see that is vary between 128 to 191. Yes, this is class B. 192, yes, 192 is between 192 and 223. Yes, this is class C. Like that, you have to identify and understand the the class of the IP address. Okay, and then here 127 is missing. 127 is dedicatedly kept for the loopback adapter. Means if your
Yes.
net 1 second. Yes, Harish.
Sorry, yes, sorry. Mic is unmuted. So.
No, no. Are you guys able to hear me?
Yes, yes.
Okay, fine. Yeah. So this 127.0.0.1 is the loopback adapter IP. Say for example, if you want to verify your network interface card health, okay. Say for example, if you want to see whether your network interface card in your laptop or computer or desktop it is working fine, you can try to ping 127.0.0. Any number between 1 to 255. I'll give 13. See, it is pinging. That means your network interface card is working perfectly fine. So this 127, if the IP address is starting with 127 and the remaining three numbers can be anything, okay, that is called as loopback adapter IP address. It is dedicatedly kept in order to check the network interface card health. Okay, and now you may have a question, sir, how can I identify whether my IP address is public or private? I will strongly recommend you to go and watch the IP address classes. You have it is there in the infrastructure video. Okay, infrastructure videos. You have that IP address. Very beautiful video. You just go and see. Okay, so see in each and every classes, dedicatedly one IP is dedicatedly kept for the private usage. In the class A, it is 10. If an IP address that is begin with 10, if an IP in the class B, it is 172. In class C it is 192. Okay, if an IP address that is beginning with any of these three numbers, that is called as private. Apart from this any number, that is called as public. Okay, if an IP address that is starting with 10 or 172 or 192, that is called as private. You don't have to pay for it. Apart from that, anything that you use or anything that you purchase, that is for the, I mean, that is public IP and you have to pay for it. Okay, so this is what the IP address is all about. Okay, so I think with that all the network services we have covered. Okay, let me stop the recording and then I'll take the questions.